Welcome back to part 2 of our Frigate series. If you're new here, Frigate helps manage and analyze video feeds, and Proxmox is great for virtualizing your server. Today, we're upgrading by adding the Google Coral TPU, a device designed to speed up machine learning and improve object detection. This upgrade can make a big difference if you're dealing with multiple cameras or want to reduce the strain on your CPU. Let's dive in and see how to set this up on your Proxmox LXC server. So why consider the Coral TPU? It helps Frigate work faster by handling machine learning tasks that would otherwise slow down by your CPU. This means better performance, especially if you have several cameras or want to reduce latency. The $30 PCIe Coral is a budget-friendly option that can handle multiple CCTV feeds efficiently, freeing up your CPU for other tasks. In this video, I'll show you how to install the TPU on your hardware and set it up with Proxmox for Frigate 0.14. This guide assumes you have some basic knowledge of Proxmox, Linux commands, and Frigate. If you need a refresher, check the description for helpful resources and links. I first open my laptop case and look for the Wi-Fi module. I then remove the IPEX connectors and remove the chip by unscrewing the M.2 slot. Now, we can place the Coral chip into the M.2 slot and place the screw back. Once that's done, we can close the case and get the laptop up and running. To start, we go to the Linux section 2A and perform the first two commands to check for compatibility and check if we have the Apex driver installed. After that, we proceed to the TPU's PCIe driver installation. We are going to do step 1 to 4 in both PVE shell and to the LXC container to avoid problems later on in the installation. In step 1, we are adding the repository of the Coral TPU and obtaining the apt key, because in step 2, we are going to install the Edge TPU runtime packages. Make sure to do an apt update before installing the packages. In step 3, we are going to add the root user in the Apex group in our PVE container, and finally, in step 4, we're going to restart by pressing the reboot on the top right. Now, we're going to repeat what we just did from step 1 to step 4. Add the repository, install the packages, but this time, we also need to install GNU PG so that we can add the TPU's runtime package apt key. We can do this via sudo apt install GNU PG. We then add the root user to the Apex group. And for the last step, instead of restarting the entire Proxmox server, we're going to restart the LXC container instead. Now, in this part, we are doing step 5 in the LXC container. But we are greeted with an error, LSCPI not found. We can fix this by installing PCIe utils. After that, we can redo the command in step 5. After that, we are now stuck at step 6. Originally, we should expect an output with the directory of the PCIe driver. So I started to do some research, and in the Home Assistant forum, I found some helpful information from the user TMJPugH. I first check if the driver is loaded in some capacity that is recognized by my computer. I installed lshw in the LXC container with sudo apt install lshw to check the PCIe driver. The driver is there, but is currently generic and an unclassified device, which led me that there is a problem with the Apex driver installed from step 2. I found the solution by a forum discussion made by Jangle98 in the Google Coral GitHub page. I followed his instructions and first switched to the no subscription PVE in my Proxmox repository. To switch to no subscription in Proxmox, first we go to the PVE container and go to the shell. I first did an apt update and checked the warnings and errors in the output. If we check the repository tab, we can see there's an exclamation mark. The goal is to replace the subscription repository to the non-subscription repository. To fix this, we are going to edit two files. First, we are going to use nano to edit the files. Nano to the PVE enterprise list file and replace the original line to the no subscription line. It starts with the deb and then the URL of the repository. I have provided in the description of this video the commands and the text to replace. Next, we need to edit the Ceph list also to non-subscription. First check for either words which are Quincy or Rafe. You need to replace it with a PVE no subscription. My Frigate container is a Debian bookworm, and the URL is using Quincy. Therefore, I should use the Quincy URL of the no subscription of Proxmox. After finishing editing the two files, do an apt update and check if the errors are gone. I now only have a warning of the TPU's repository, which is fine. We can now proceed to the fix for step 6. We head over to the GitHub page by ByteLake Coral in LXC and follow the first step, which is to edit the Proxmox LXC config file for Frigate. We're going to use nano and edit our LXC's container config file. it's usually located in the etc directory. The goal here is to copy the lines that will pass through our TPU to the LXC container. Since I have already installed Frigate, I'm going to only add lines only related to the TPU. I decided to copy any line that I don't have yet in my configuration and fix it later. If you're doing this in a fresh installation, copy the whole text and start the container. If there's an error, Proxmox will tell you which line is not compatible. If you have an AMD or NVIDIA driver, unfortunately, you need to research to pass through the driver to your LXC container. I would try to do it with ChatGPT first, then research via search engine. Let me explain. In this process, we're trying to get our LXC container to recognize our server's driver and use that in this LXC container, which are lines of code we've just copied for Intel's built-in GPU and the Coral PCIe. Heading over to the Proxmox forum, we found a solution fix for the problem in step 6. It's the solution from LiloBZH, and that is to uninstall gasket-dkms and use the dbuild command. We need to remove gasket-dkms first in the PVE container and then install git, devscripts, and dkms. After that, we need to go to the home directory and clone the repository of the gasket driver. We go to the directory using cd and then use the dbuild command. After that, we would want to return home and use the dpackage command in order to install the new gasket Debian package. I then installed the headers in my PVE container and I did an apt update and an apt upgrade. Finally, I rebooted the PVE container in which Proxmox is restarted. Our PVE container now detects the Apex driver, and therefore the TPU driver is now functional. The only thing we need to do is make it pass through our LXC container and also make it functional there. If you've already installed Frigate via Proxmox from other sources online, you might encounter mounts failed because the file or directory does not exist. If you don't see this error, you can skip ahead to the next part. But in case you do, to fix this issue, we need to edit our Proxmox LXC containers config file again. The goal is to remove or comment the lines related we see in the screen. The key here is to troubleshoot and find which line in the LXC container is related to the error. Usually, the error name is related to a line in the code. Either you comment the line or remove it. Save once you're done and start the container. It seems we need to address the apparmor in the configuration file. We will need to remove or uncomment the line that is related to apparmor. So I edited the config file with nano, saved the file, and start the container. We can proceed at step 6 to check if the driver has loaded. An output has been given, and it is the directory we are looking for. We have completed step 6 and the driver is fully working. Finally, we just need to configure Frigate to use the Coral TPU. I first check my Docker compose file config and check if the PCIe driver is commented. It looks like it's not yet, so we have to edit our Docker compose file. We're simply going to remove the hash to make it active and uncommented. Once that's done, we're going to save the compose file and start the Docker container. We can now head over to Frigate to edit our configuration file. For the final step, we need to add our TPU detector. We head straight over to the config and add the lines of the PCIe driver. This was recorded before I upgraded to Frigate 0.14 by the way, but the configuration of detect is the same. I forgot to remove the model below the detector, which led me to an error. It seems I got too excited. So to fix this, I needed to edit the config directly in Proxmox. I went to the config directory and edited the config file and removed the lines related to model because this is only for OpenVINO. We can see the model lines are gone in the System tab. The Coral TPU is the one used to detect, as we can save the performance of the CPU for other processes active in Frigate and for other LXC containers in Proxmox. Upgrading from Frigate 0.13 to 0.14 did not give any problems to the TPU driver. A warning when upgrading to 0.14 as existing events won't show up in 0.14 as a new system is implemented. Also, masks and zones might or might not work as there are changes that are not backwards compatible. I recommend you read the major changes in the release page before upgrading. When I upgraded to 0.14, I went over the Docker compose file and modified the image URL to the latest Frigate 0.14 URL and saved. And all you have to do is Docker compose pull and Docker compose up to apply changes. I did not do the Docker compose pull and Docker compose up since my container is already up and running, but run these commands to update and start Frigate. Upon checking my configuration in Frigate 0.14, and it still works properly. Thanks for tuning in to part 2 of our Frigate series. I hope you found this guide on integrating the Google Coral TPU with Proxmox and Frigate helpful for boosting your system's performance. If you found this video helpful, make sure to hit that like button and subscribe so you don't miss out on the next installment. In part 3, we'll be taking your surveillance setup to the next level by showing you how to view your RTSP streams directly on your television using a single board computer. I'll be using an Orange Pi 1 to demonstrate how to effortlessly stream on your CCTV footage to your TV. Stay tuned for that. And if you have any questions or run into issues, drop a comment below, and I'm here to help. Thanks for watching, and I'll see you in the next video.